Okay, I will just go through question 5 to 9 quickly, but you can actually take your time and get it done, okay? Okay, for this, correlation coefficient is negative 0.89. So what do you know by it? Meaning when the altitude increase, the temperature will decrease. So this one, when it's a negative correlation, one up, one down. For this data, the covariance was calculated as this if the altitude were converted to kilometers. So as for S, whatever change you make to S will change. So for R, no change. But S, if you times one of for meter to kilometer, what you have to do, you have to divide with 1,000, right? So you divide your S with 1,000 as well. Okay, I think that shouldn't be a problem. R, no change, okay? Okay, this one, the sum of these products, sample covariance, correlation coefficient, the table given, put in the calculator and just get the values for me. That shouldn't be a problem. If each of the scores in both sets is double, that means mu times with 2, nu times with 2, what will happen? Nothing will happen. Your correlation coefficient will stay the same, it won't change. Each of the scores in both sets is multiplied by -1. M is multiplied by -1, n also multiplied by -1. What will happen? No change because both are multiplied with the same sign. Each of the scores in set M and N is multiplied. Okay, M is multiplied by 2, N is multiplied by -1. It doesn't matter if the values are multiplied in different. Let's say M with 10, N with -2. Doesn't matter. It's just that one is positive, one is negative. Your R will change to positive. That means if it was originally negative, now it will change to positive. Okay, it won't change in value, just the sign only will change one. Okay, so let's look at this one. I don't think this one should be a problem. They've given you the table, you calculate the mean and median. This is chapter 1, calculate the standard deviation. Now the standard deviation for net income, after 10% of the tabulated incomes have been deducted for social fees. So 10% is deducted, so you are left with 90%, isn't it? So you just take your standard deviation, make sure you take in 4 decimal places, and you times with 0.9. Alright? Alright, okay, times with 0.9. Make sure you take in 4 decimal. Why 0.9? Because after deduction of 10%. Then to find covariance and correlation coefficient shouldn't be a problem. Okay, what is the significance of this? It's a positive relationship. Age go up, ID income go up. So that shouldn't be a problem as well. This part, okay, let's look at this. What is income? What is inside income? 90% is net income. That means 90% is what you take back, net income, and 10% goes to social club fees. If you read the question, you should understand what I'm saying already. Inside income, you have net income, you have club fees. Net income is 0.9, club fees is 0.1. So between income and age, just now you calculate 0.96, right? That means between net income and age, and between club fees and age is also 0.96. It won't change. Understand? If income got another input inside here, that input also will be 0.96. Understand? If income and age is 0.96, everything inside income and age will also be 0.96. What about between net income and club fees? It will be 1. Perfect relationship because got formula. If income is 1,900 is net income. 100 is club fees. It's a formula because this plus this is this. Anything related with the formula is perfect relationship. And in this case, it's positive. Why? If income increase, this will increase. This will increase. That's why income and net income is 1. Income and club fees is 1. Understand? So social club fees and income, 1. Social club fees and age. Social club fees and age, 0.96. Age and net income, 0.96. Just play this video again to try to understand it. Take your time and understand it, alright? Okay, so these values are given. Calculating the covariance shouldn't be a problem. Showing the correlation coefficient shouldn't be a problem. Significance, no relationship because there's nothing going on there. So there's no relationship, okay? Okay, if each of the dollar was reduced by 15%, it will affect the SXY, but it won't affect the R. So you just, if reduced by 15%, you times with 0.85 to your SXY. Your SXY will change. RXY, no change. RXY only change when one times with negative, one times with positive. Okay, I'll just quickly go through, then you can actually do it at your own time, okay? All right, so find the correlation coefficient for this. Plug in the calculator, X and Y. you get negative. Why negative? The older the car, logically, the older the car, the cheaper it should be. Older cars are cheaper than newer cars. Now, between model year and price, how to find this? You know, between age and price just now is negative 0.84, right? Okay, between year and price, between age and year is -1. We did that before when we did perfect relationship. There was another question. It is perfect negative, right? Because as the year increase, the age will decrease. One up, one down, -1. So because these two is a perfect relationship between these two, it will still be 0.94. Only the sign only you need to check. So year increase, what will happen to the price? It will also increase. As the year keeps increasing, the price will increase. It will be 0.94. Okay? If the price of a 10-year-old car was increased to 8,000, what would be the effect? If an old car, you go and increase the price, what will happen? The relationship says when the age go up, price go down. But now what's happening here? The age go up, the price go up. So this will weaken the relationship because it will behave like an outlier. Understand? So for this part of the question, just replay the video. You don't know, then just ask me, okay?